Hi, in this video, I'll be talking about multiple regression using SPSS. We will start by looking at the following example. A restaurant manager was interested in knowing the factors that affect how much diners tip. He randomly selected 10 customers on a particular day and recorded their age, whether food was served promptly, where 1 is yes and 0 is no, cost of dinner, and tips in dollars that they gave. The data is given in the table below. The data is shown here. We will be answering the following questions. Obtain the multiple regression equation. Identify the coefficient of determination and interpret it. Interpret the coefficients of each of the independent variables of the regression equation. Identify the 95% confidence interval for each of the regression coefficients. Conduct an overall hypothesis test to determine if the regression equation is useful in explaining how diners tip. Use a 5% significance level. Conduct individual hypothesis tests to determine whether some of the variables should be dropped. Use a 5% significance level. Conduct tests of multicollinearity. Based on the results obtained, update the model to fix the problem of multicollinearity if it exists. Next, we will be taking the data into SPSS. Once the data is in SPSS, we go to Analyze, Regression, Linear. In the dependent box, we put tips, which is my Y. In the independent box, I put all three independent variables. And then I'll click on Statistics and then check confidence interval. My alpha here is 5%, so my confidence level is 95. And then I'll also check the box that says Collinearity Diagnostics. Then I'll click Continue and then OK. My result shows up. From this result, I will be using this first table, this second table, which is the ANOVA table, and this third table. So those are the three tables that we need. So we're going to be using those three tables to answer our questions. Going to the A part of the question, we will be obtaining the multiple regression equation. We look at the result from our table here, from our SPSS output. The regression equation is of the form y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 because we have three independent variables here. My epsilon in this case is approximately 0. So if we look in the table from our SPSS result, we will find the values there. So our regression equation is going to be of the form y equals to 4.654, which is my estimate for beta naught, negative 0.055, which is my estimate for beta 1, 5.081, which is my estimate for beta 2, and 0.088, which is my estimate for beta 3. So this will be my multiple regression equation. We can see that our y is representing the tips, x1 is representing age, x2 is representing whether prompt or not prompt, and x3 is the cost of dinner. Going to the B part of the question, identify the coefficient of determination and interpret it. We are going to be using the result from this table. The coefficient of determination is r squared, which from that output is 0.954. So my r squared we can interpret as follows. About 95.4% of the variation in tips given by diners is explained by the regression model. The remaining 4.6% is unexplained due to other factors. Now to the C part of the question, interpret the coefficients of each of the independent variables of the regression equation. Again, we'll be looking at this table right here from our SPSS output. Now, based on that, we are going to be looking at estimates for beta 1, beta 2, beta 3. The estimate for beta 1, which is B1, is negative 0.055. We interpret it by saying for each unit increase in H, the tips decrease by 5 cents, all else being held constant. My B1 here is negative. My B2, which is 5.081, estimate for beta 2, is interpreted when service is prompt, the tips increase by $5.08, all else being held constant. Lastly, my B3, which is 0.09, is interpreted for each unit increase in cost of dinner, the tips increase by 9 cents, all else being held constant. Going to the D part of the question, identify the 95% confidence interval for each of the regression coefficients. I will look again in this part of the table. This contains the 95% confidence intervals for each of the regression coefficients. For beta 1, the 95% confidence interval is negative 0.158 less than beta 1 less than 0.049. 95% confidence interval for beta 2, 3.012 less than beta 2 less than 7.150. And 95% confidence interval for beta 3, 0.040 less than beta 3 less than 0.135. The E part of the question says, conduct an overall hypothesis test to determine if the regression equation is useful in explaining how Dynat's steep use a 5% significance level. So we're doing F test under ANOVA. We look at this null and alternative hypothesis. The null is the model isn't statistically significant. In that case, my beta 1 is equal to beta 2, which is equal to beta 3, which is equal to 0. My alternative, the model, is statistically significant, which means at least one of the beta i's is not equal to 0. The result is in this part of the table. I can be able to see the F test there, but we're going to be making the decision with the p-value. The p-value is seen right there in the table. The p-value here is 0.000, which is less than alpha, which is 0.05. Hence, we reject the null hypothesis. We can thus say that the model is statistically significant, and at least one of the independent variables is significant in the model. Going to the F part of the question, conduct individual hypothesis tests to determine whether some of the variables should be dropped. Use a 5% significance level. I will again look at this part of the table, and I'm going to be doing individual tests for beta 1, beta 2, and beta 3. For age, I will be performing a test for beta 1. The null will be beta 1 is equal to 0 versus beta 1 is not equal to 0. From that table, I can see that the p-value is 0.242, which is greater than alpha, which is 0.05. So hence, we fail to reject the null hypothesis. This means that age is not significant in the model. It should be dropped. For prompt, my null is beta 2 is equal to 0 versus beta 2 not equal to 0. The p-value from the table is 0.001, which is less than alpha, 0.05. Hence, we reject the null hypothesis. This means that prompt is significant in the model. For cost of dinner, my null is beta 3 equals to 0 versus alternative of beta 3 not equal to 0. The p-value is 0.004, which is less than 0.05 of a value of alpha. Hence, we reject the null hypothesis. This means that cost is also significant in the model. The last part of the question, we're supposed to conduct tests of multicollinearity. based on the result obtained, we're supposed to update the model to fix the problem of multicollinearity if it exists. Now, there is multicollinearity in the model if any pair of independent variables have high correlation between them. So to do this, we'll use the result from this table. We look at the column with the VIF. My VIF is the variance inflation factor. Now, since the variance inflation factor for all the variables are less than 5, we don't have a problem of multicollinearity in the model. But if there is any of them that is greater than 5, then multicollinearity will exist. To be able to fix it, we always try to remove one or both of the variables that are interfering in our model. Thank you for watching this video.